is Nikhil. So today we're going to talk about container infra, so how to secure them. So I need a quick raise of hands before we start. How many of you here work with containers? Okay. How many of you, so most of you already know what containers are and you use them daily? Okay, perfect. So for those who do not know about containers, let me just give a small demo. So I have a Mac laptop here. So this is a bare metal server. It has an operating system. And on this laptop, I can install a hypervisor like ESXi or KVM. With a hypervisor, I will be able to spin up more virtual machines, and I can run a Windows computer or a Linux computer on the top. So that's virtual machines. So this is all like 10, 15 years ago. And maybe containers, you can say like 10, 12 years ago, where we thought, why do we need each virtual machine to have its own kernel and it's adding so much overhead? So we separated the kernel. And we said, OK, let's do containers. So we brought this thing called Docker Orchestrator, through which you can deploy containers, and you can minimize the flow where we can have very small workloads through which you can do development. So if you observe in most applications these days, most of the applications, you have a statistics DB, you have a graph database, you have application server, and multiple things packaged into one. And if you have each of them at its own virtual machine, the space would be so high and it will be wasting so much energy or compute. So once you convert them into containers, you are just using the kernel from the hypervisor or the bare metal and making it easy for the end users to use. So for this talk, there is a couple of ways we can do. If you have a laptop, personal laptop, through which you want to try these commands, we can do this hands-on. We'll be talking about 3 or 4 open source and free tools through which you can scan your containers. And I have all the commands in there. They're pretty easy. You can install Docker, and after that, it's easy to follow. We'll do that live. If you don't have your laptop, that's still OK. We'll share the slide deck at the end, and you can go home and practice these. I also plan to put this on some blog post or something so that it's easier to follow that way. So let's go ahead and start. This is a snippet was taken from last week in AWS from 2020, I think. They said there are like 70, so 2021, there are 17 ways to run containers on AWS, and maybe now there are like 20 more ways. If you have these many ways to run containers, that means you have too many containers running in the AWS. So we need to secure them before we deploy them. That's the whole point of this talk. How do we do it? And when it comes to security, there are 2 ways of scanning a container. First thing is a static analysis. Static analysis is nothing but you build a container, you don't need to run it, you just scan the image itself and see if there are any vulnerabilities, and you can fix them. Dynamic analysis is something where container is actually running and the application is running, and you find bugs in that. So for today's talk, we'll be going through static analysis and multiple tools for that. You can use your own container, or you can just download a damn vulnerable container like that. So it is available in the Docker Hub, or you can just use this command, docker pull vulnerables web dvwa, and you can download it to your desktop. And what we can do is, in my case, I already have this container. As you can see, I already downloaded this. This is around 700 megabytes. If you want, you can download a smaller container from the Docker Hub. We can use it to scan. But this is one of the ones which we will be using for today's talk. And you can do Docker images command, through which you can see what images are on your laptop. To run this specific container, we use this command. What I just do is I take this, I execute this, and it's basically kickstarting the container. I'll be able to open localhost and access this. And I can click on create or reset database. And it's successful. And username is admin and password is password. So it's It's a vulnerable container, so it's easy to get into. In theory, this container is used as a lesson in most cybersecurity conferences, where they teach you how to learn vulnerability scanning, where you tell you brute force, command injection, SQL injection, and all these tutorials. So this container, we are just using it for static analysis, but in reality, when you run this, you can use it to learn a lot of other cybersecurity lessons. And it's way too easy. There are lessons online, there are tutorials online to follow and understand all these things. So to come back to that, come back to our talk, now that we have this container, so as you can see, we just saw all this, we saw the setup, and we were able to log in. We'll start with our first tool. It's called Docker Bane Security. So this was built by Docker itself. It's very simple to use. There is a command for it. You just run this command. It not only scans one of the container images, but it scans all the container images in your laptop. So it's very easy to use. When you run this is the first setup where you pull Docker Bane Security. It's a container itself. And when I do Docker PS, this is a container that I just brought up now. And when I run Docker Bane Security, this is the log that I get. It will give me multiple warnings, information, and notes. And at the end, I see a score. It says, hey, I did 105 checks, and your score is 5. Because, of course, the vulnerable container has a lot of outdated packages, old packages, which are really, really vulnerable. So this is just a basic static analysis from Docker Bench. Your intention should be getting the score way too high, maybe in like 70 or 80 before you can deploy. If you have some critical vulnerabilities, it's better not to deploy it to production workload and get it attacked. So this is just a smaller image of how Docker Bane Security works and what it does. But let's jump into our second tool. It's called Anchor. It's a company. So they have two tools. One is called Sift, and other one is called Gripe. We are not going to be talking about Sift because Sift is to get a software bill of materials. So how many of you here know what SBOM or software bill of materials means? Okay. Does anyone want to answer that? Your choice. You want to answer that? You can answer it. Okay, so software bill of materials is if you have an application or an image, you use a lot of other open source tools inside as packages. So what it does is it scans the entire image and shows, okay, you are using Apache Wildfly this version, you are using Apache Spark this version, you are using Docker this version. It builds out all the details, and these are really important when you have an ISO audit for your company or for application or for product. ISO audit checks, they ask, what are you using in your software? Can you list it out? What are the versions of each of every material in the software that you are using? So you have to show them each package when there is a software audit for your company. But today, we'll be using Gripe because that is a free tool which we'll be using for vulnerability scanning. And since I have a Mac laptop, I just did a brew, tap, and brew install. If you have a Ubuntu or other system, you can do it from there. You can do an apt install on a Ubuntu system. And again, you can just bring that up. And what I did is for my container, I just did scope all layers. So there are a couple of ways. I can just scan the container itself with the tag. What it does, it will just scan the container normally. But when I do scope all layers, it will go through all the image layers and it does a deeper scan. You could say it could just a deeper scan. And the output looks something like this on my laptop. It says, hey, it has Apache 2, 2.4.2.25. This is a version. And this version has a vulnerability fix, and this is a vulnerability number, CVE number. And the criticality is here. If it's negligible, medium, high, or low, everything will be visible. So it will basically list out all packages that are inside your container, and it will show you which ones are affected by which vulnerability or not. So this is more better than Docker Bench, right? Because Docker Bench gives me a score, and I don't know where to start. I don't know, like, okay, what should I fix in my container? I have no idea. But here, I actually have a list of CVEs, and it will tell me which packages are vulnerable. So similarly, it has like PHP version. This is the version you're using, and this version has a fix. And this is a CVE, medium, critical. So What does a CVE mean? Anyone? Yeah.
It's a vulnerability standard by MITRE,
Yeah,
repository of known vulnerabilities like
that's correct.
side channel attacks, SSH, privilege escalation. Yeah, it could be in different
Yeah.
stacks.
Yeah. So CV, as she said, it's a common vulnerability and exposure. And there is a score called CVSS, Common Vulnerability Score, through which you say a vulnerability is low, medium, high, or critical. So there is a score that you assign to each vulnerability or a weakness in a software. And let's say there was I think most of the people's holidays were low in last year because of Log4j vulnerability, which was a critical vulnerability. And I was gonna go out for like Christmas, and I had my wedding like on 29th December, and I was working until 25th December to get it fixed and verify all the images. I'm a QA engineer, so whatever my devs fix, I have to test it before it goes out. So I didn't have any Christmas, so I just had to directly go to my wedding and get married. So Log4j was a critical vulnerability, and if we didn't have the fix, it was very easy for an attacker to go and break down our system. And I work on the SD-WAN software, which is used by most banks. You can talk about Citibank, Bank of America, or gas stations and everything. And if their routers get hacked, we are going to lose lots of business. So that's the reason the critical vulnerabilities are important. So if we can actually find these earlier before you deploy your containers, then it's a lot better. The reason I said we are only doing containers today because in my own company, in our architecture, 4 years ago, we didn't have a single container. Now, we use application server as a container, our messaging server is a container, our database is a container, our stats database is a container. So we have containerized each and every service that we have. None of them is running as a standalone service. So we also reduce the footprint a lot. I'll give you an example. So StatsDB, we use a thing called Elasticsearch. So Elasticsearch can be containerized. And for GraphDB, we use a thing called Neo4j. It is containerized. For App Server, we use Apache Wildfly. Most of these are open source, so Wildfly is containerized. And for messaging server, we used to use Apache Kafka before, but now we moved on to a different container. I don't remember the exact name for it, but it's an open source project by Linux Foundation, and we use that messaging server now. So this is a gripe tool. So now we come to my favorite tool called Snyk. How many of you heard of Snyk? Okay, perfect. So you're not wearing, okay. The t-shirt looks similar, it's Datadog, sorry. So Snyk is a tool I've been using for the past few years to scan containers. The reason I use it is because I can use it from CLI or API, and also there is a very simple way to use it via UI. Because earlier Docker, Bane, or Gripe, they are mostly CLI-based tools, and it's not easy for me to show my leadership team that, hey, this is a good tool to use, and hey, this is a list of vulnerabilities. My VP will be like, what? What are you doing? So if I have Snyk, I can create an account, and if I do it from CLI, Snyk also does the same thing similar to Gripe, It will tell me, hey, this is a vulnerability on this package. This is a CV. More information is here. This was introduced through this. And this is where I found this in your image. And it will also show where it is fixed. This is similar to Gripe. It's okay. I mean, it's not that great. But if I use Snyk from the UI, it actually has a bunch of these integrations where I can have a container in the Docker Hub, or I can have it in AWS, I have it in Google Cloud. I can have it anywhere, and I can scan it directly. So the output looks like this, where I take this screenshot, and I'd say, this is my image. I have like 1,000 vulnerabilities in there, and 100 are critical, 400 are high, 500 are medium, and 22 are low vulnerability. So this looks a lot better when you present it to your leadership team than a CLI-based output, right? So Snyk has a free version, and you can use it to scan some set of images. So if you have some test images, just push it to Docker Hub or AWS, connect to your Snyk account, and it's free to scan. So I did this scan a long time ago on one of my images, one of the Docker container that I built, which is similar to a vulnerable container. And this is the report that I got. If you really want to use it via CLI, it's possible. You just take the API auth token, connect it to your terminal, and run the scan. This is what I ran for the damn vulnerable container, and this is the output that I got. If you want UI, as you can see, you can get it like this. And there is also a filter where I can actually filter by criticality level, which of them are fixable, which doesn't have a fix, which of them are like mature, or which of them has no exploit. What does exploit mean? Anyone? What does exploit mean? Okay. So in any vulnerability, there can be a weakness in the software, but it has to be exploitable. If a hacker gets into your system, but he cannot do anything to your system, it will be a low score vulnerability, and you cannot exploit it, and you cannot cause any damage to the system. When you can exploit it, you can actually traverse to the system and cause damage. So here it says 1,000 of them do not have any known exploit, or nobody has exploited them. Doesn't mean that it is good. It's just that as of now, nobody has created a malicious code that can go and exploit the system. So yeah, this was a very quick session, just 15 minutes. And if you want to do hands-on, I can share the commands. I'll share the PowerPoint. And these are some of the references that I used. Since we have more time, any questions, Q&A? I got the mic, so.
You put the references?
References? Yeah. So when I was writing this talk, I just searched Google, which are the top container security tools. I know a couple of them. I used Gripe, and I used Snyk before. And I wanted a Docker Bench, but Docker Bench is very tough to use. And if you are building your own containers, then there are some best practices here that you want to take a look. Basically, for image building and how you are building your Docker image, you have to reduce your attack surface. There is like one open-ended question I want to ask everyone. Now that we have moved from a bare metal machine to a virtual machine, to a container, to a microservice, do you think we are more secure in this world, or we are less secure? What does everyone think? Same? Okay. There is no wrong answer. So.
Yeah.
Oh. More secure? So, but did we reduce the attack surface, or did we increase the attack surface? Yes. Yes. Yep. That's pretty good, because think about a scenario where you have a virtual machine and you have thousands of packages inside. You don't know where the attack is come from. But now that you have separated them into separate code blocks or services, it's easy to scan them separately. And if there is an exploit, you know exactly which part of it is exploited, and you can fix it directly. Otherwise, if it's virtual machine, you have to think of the system as a whole and multiple services in there. Now that you have demarcated them, we are trying to reduce the attack surface. But on the other hand, if you think other way, you have actually increased the attack surface because you have thousands of different applications now. So yeah. Yeah, you have increased the number of things, but it's easy to point out which one is vulnerable or not, rather than system as a whole.
When you go to the S model, then you have this whole dependency thing that you don't know.
Yes.
And that's where the attack surface is increased.
Yes.
The supply chain.
Okay.
I said the same.
Yeah. Any other question? No, Anchor. Anchor is a company that gives you Gripe. No, I wouldn't say it's a subset. It's a different type of scanner, and it's an open source scanner too. So Anchor actually uses two tools for free. They have Anchor engine itself. It's a commercial tool available. So if you're like a big enterprise, if you don't want to do like Gripe or Swift, you just pay Anchor to use their Anchor engine. It is actually pretty good. I've used that too, the enterprise version. But since we are talking only about the free versions where anybody can just go download it from Google and use it, I was talking about Gripe. But Anchor is kind of similar to what Snyk does. It has a UI version. You go to UI module, connect your Docker containers, and it gives a report on the UI. Oh, yeah, if you have Snyk, you are pretty much covered because for static analysis, they do the same thing. But when you're talking about dynamic analysis, you actually need a red team or a penetration testing team that checks for vulnerabilities. And as I was telling, the best place to practice vulnerabilities is this one. You have all types of top 10 OWASP attacks. You go here, you search Google on how to do each of this, and this is where you go ahead and start and learn dynamic analysis or just vulnerability scanning per se. We use some, not all of them. I mean, at least I use Snyk for personal projects, and we have our own tools to scan. Yeah. So we have the new tools like Thousand Eyes and everything, which does visibility, but they're not really a scanning tool. But Cisco has its own thing called SecureX, which actually scans all these workloads. But it's not open source. That's the reason it's not in this presentation. Yeah, we sell it, but it's not free. It's not free. So that's the reason it's not in here. Yeah. So this is helpful for if you have your personal project or like startups or something where you don't want to pay for a thing. This is the best place to start. I mean, you have so many free tools. They do 95% of the job. If you pay for Metasploit, some other like licenses or some other scanners, Rapid7, we use Rapid7, right? Rapid7, I pay for the license. It is good. But it might find one or more two vulnerabilities, but yeah, you just pay for it. So yeah, that's what you get, but these are as good enough as a paid tool. Yeah. Any other questions? Okay, good.
I run a product called Tetration. We're a data center analytics and security tool focused on different form factors, workload, containers, VMs. So our goal is microsegmentation. We prevent east-west lateral movement, in case you're interested. Yeah.
Yeah, Cisco does contribute to open source. But if I come across any open source project, I'll let you know. But there are free products. So like most of our Thousand Eyes and some other acquisitions that we did, AppDynamics and everything, there are free versions of it online through which you can scan endpoints, network devices, and everything. But specifically to containers, best place is like start with the open source tools and then go for higher versions. Yeah, of course. Yeah, thank you. Yeah, I think we're early for the raffle, but I gave you guys 15 minutes saved you 15 minutes of time. Yeah.